Hi my esteemed viewers out there, it's so good to have you watch our very first UTME video on this channel, New Track Mathematics video. I'm Andy, your anchor on this channel, and on today we are going to take you on a topic, number bases. At the end of this video, I assure you should be able to do the following. Perform the four basic operations: multiplication, division, addition and subtraction in number bases. Convert from one number base to another. Practice sample questions from past UTME questions, and properly manage your time during the exams, since time is an essential factor during your Jamb exam. Now, as an introduction into this topic, we want to look at the fact that number bases are a system of counting in which some certain units of numbers makes up a bundle. Now, the bundle, thus, on the other hand, forms the next place value. Now, the placing of the next digit shows the value. Now, when counting is generally done in base 10, we do call that the denary number or the decimal number. We should also note that base 2 is otherwise called the binary, which is very important to note because it is used in computer applications today, while normally base 8 is known as the octal number. Now, for you to carry out solutions or practical solving of questions on number bases, there are key notes we must take good note of. Now, we are going to analyze 4 key points or key notes we should note if we want to successfully solve a question on number bases. Keynote 1. When performing basic operations like the addition, subtraction, the multiplication and division of number bases, it is always advisable that you convert all the values to base 10, and if necessary, you have to convert them back to the needed base so as to get your final solution. Now, take for example the value that is shown to you on the screen. 6R7 to base 8 equal to 511 to base 9. You are required to find R. Now, in this kind of question, you need to convert 6R7 base 8 to base 10 to get the value in base 10, and 5119 to base 10 to get another value in base 10, so that you can now carry out your solution on a common base to find the value of R. Now, another point you need to note, keynote 2. When converting from other bases, which are bases like bases 2, 3, 4, 5 to base 10, it involves 2 methods. I analyzed 2 methods in most of the samples I will be giving to you. The first method is power expansion method, and the second method is a successive multiplication method. Now, for UTME purpose, where time management is very important, I always advise students to solve using the successive multiplication method, and that is the method that is adopted in most of our sample solutions. Now, keynote 3. When converting from base 10 to other bases. Converting from base 10 to other bases involves continuous division of that given number in base 10 by the required base to be converted to. It might be base 2, it might be base 3, such that at the division stage, the remainders including the zeros are recorded until the division is completed. And to get your result, you need to arrange the remainders from the below to the top, which will give you the result of the conversion. Samples will be shown in our sample practical sample questions. Now, keynote 4 to take note of is when you are converting from one base to another. Let's say you are converting from base 8 to base 4. What is required? This involves the conversion of one of the base to base 10 and then converting the results of that base value to the required or expected base value using continuous division. This might sound kicky, but take your time. During the practical sample, we're going to show you examples on how this can be carried out. Now, the final keynote you need to take note of is keynote 5. Now, when carrying out addition and subtraction in any other base that is other than base 10, what is required from you? Now, addition and subtraction in any base other than base 10 is just the same. The only exception is that the number or the digit should not exceed the highest digit of the base. This will be illustrated in our sample questions, as we'll always tell you. Now, for multiplication and division, it is better for you to convert to base 10 and carry out your operation in that base 10 before reconversion to the required base. You're going to see a practical sample of all these keynotes that will be explained to you. Now, let's take out time to carry out some real-time sample questions on these key notes that have been shown to you. And as you carry out these sample questions, I want you to analyze them using these various key notes that have been shown to you on the screen. Now let's go to sample 1.
All right, let's look at the first practical sample question, and it says convert 72 base 6 to a number in base 3. Now I want you to note on this question we are going to be looking at keynote 2, and those keynotes 2, to solve that we need to convert 72 base 6 to base 10 before finally converting it to base 3. Now, to go about doing that, we'll convert 72 base 6 to base 10. Now, I told you under that keynote that you should use 2 methods, but for the sake of Jamb, because time is truly important, I will appreciate you use the successive method. Now let's look at how to go about using the successive multiplication method to solve or convert 72 base 6 to base 10. Now we are going to, first of all, step 1, convert 72 base 6 to base 10. Now, to go about this using the successive multiplication method, we will say 72 base 6 will be equal to 7 times 6, that's the base. This will give you 42 plus the next value, which is 2, that will give you 44. You see, using this method, you can easily convert it to base 10 as fast as you can. So this is the result 72 base 6 will give when converted to base 10. So step 2, we are going to convert 42 base 10 to base 3. Now, how do we go about this? We are going to look at using the division method when converting from base 10 to other bases, and that is exactly what we are going to do now. So let's do that this way to save this space. We are going to use the continuous division method to convert this. We are converting 44 base 10 to base 3. To go about this, we'll divide 44 by 3. Now, take note, as we do this, carry out this division, we are going to take note of the successive remainders that comes from this, and the remainders is going to end up being the result of the conversion from 44 base 10 to base 3. Now, 44 divided by 3 is going to give us 14. Remainder 2. Now we are still going to use 3 because we are converting to base 3. 14 divided by 3 will give you 4. remainder 2, because 4 times 3 is 12, then plus 2 will give you 14. Now let's go again. We're going to use 3 to divide 4. 4 divided by 3 is going to give us what? 1, remainder what? Remainder 2. Remainder 1. Now 3 divided by 1 is going to give us 0, remainder what? 1. Now let's go about this. To convert this properly, you need to count from below to the top, the remainders from below to the top. So finally, our conversion, 44 base 10 to base 3 gives us, counting that from the bottom to the top, we'll have 1, 1, 2, 2 to base what? To base 3. So finally, our 44 base 10 will be equal to 1, 1, 2, 2, 3. So in all the question, therefore, we can come to see now that 72 base 6 will be equal to, when converted to base 3, will be equal to 1, 1, 2, 2 base 3. And that will be our final result. I guess you get it. And with following this step, you can easily convert from other bases to other bases using Keynote 3 comfortably without much stress. Now let's look at practical sample question 2. It says if 2q3 base 5 is equal to 78 base 8, find q. Now this is a very important question, and you know under UTME or Jamb, time is of an essence. Now what we need to do is to convert base 5 to base 10 and also 78 base 8 back to base 10, so that these two values will have a common base. Then from there we can now simplify further to get our value q. Now let's go about it. We'll have to convert 2q3 base 5, we'll convert it to base 10, and then 78 base 8, we're going to convert it to base 10. Now converting 2q3 base 5 to base 10 gives you this: 2 times 5, remember this, 0, 1, 2, and this will give you 0, 1. So this will give you 2 times 5 raised to power 2 plus q times 5 raised to power 1 plus 3 times 5 raised to power 0. Now we've successfully converted this to base 10. Now we're going to convert this. This will be 7 times 8 raised to power 1 plus 7 times 8 raised to power 0. Now if we simplify further, 5 raised to power 2 is going to give us 25. So this will be equal to 2 times 25 plus 5 raised to power 1 is 5. So q times 5 plus 3 times, remember in indices anything raised to power 0 is 1. So the 5 raised to power 0 will give us 1. So this will be equal to 7 times 8 plus 7 times, same thing goes there, 8 raised to power 0 is 1. Now simplifying further, 25 times 50, 2 times 25 is going to give us 50. So this will give us 50 plus q times 5 is going to give us 5q plus this times 1 will give you 3. 7 times 8 is going to give you 56 plus 7. Simplifying further, we'll have to look at collecting the like terms. So this will give you 50 plus 3 plus 5q equal to this plus this will give us 63. Right? Now 53 plus 5q is equal to 63. Now collecting like terms, we'll have our 5q to be equal to 63 minus 50 what? 3, because this goes over crossing the equal to sign. So this will give us 5q equal to 63 minus 53 will give us 10. So our q now will now be equal to 10 divided by 5, which is equal to 2. So dividing this, our q will be equal to 2, and that is the value of q in this base number. So this is exactly how you can solve this question easily, by converting these two different bases to a common base, so that you can be able to simplify on a common base, which is what truly matters. So that is the value to the question of sample 2. Good. So next question, the third practical sample question on UTME videos. On this UTME video, we're going to look at this question: find the value of 110,111 base 2 to 10100 base 2. Now this one is going, you're asked to add these two number bases together. Now it's going to consume you more time when you convert this to base 10, this to base 10, then do the addition and finally convert the addition, which is in base 10, to base 2. But this time around, the much easiest method under a UTME examination condition, which time is very, very important, is to go about using your addition rule. Now, what do I mean by your addition rule? Remember, when in your secondary school stage, you've been asked, or you've been told rules that governs adding number bases. In such rule of this, we know that 0 plus 0 is equal to 0. Now we are also still going to look at 0 plus 1 is equal to 1 under number basis. And under number basis, 1 plus 0 should be equal to 1. Now under number basis, if you have 1 plus 1 is equal to 10, then you write what? You write 0 and carry what? And carry 1. So these are the values we are going to use for now. And subsequently, if we go further, you will find out that 1 plus 1 plus 1 is equal to 11. You write 1 and carry what? And carry 1. So these are the rules we are going to use as we solve these two questions. Now let's go about it. We have 1 1 0 1 1 1 in base 2. The other one, we have 0 0 1 0 1 in base 2, and we are asked to add these two numbers. Now let's go about what we have just explained. This rule is a rule we call the addition rule in number basis. Now from that rule, we say 1 plus 0 will give us what? That's 1. Now 1 plus 0 will still give us 1. Now remember, 1 plus 1 will give you 10. You write 0 and you carry what? You carry 1. Now we have 1 plus 0 is equal to what? 1 plus 0 is still equal to 1. So our value here will be 1. The next one, we have 1 plus 1 is equal to 10. You write 0 and you carry what? 1. Now the next value, we have 1 plus 1 is still going to give us 10. We write 0 and we carry what? 1. Here there is no value here, so it is assumed that it is what? 0. 1 plus 0 will give us 1. So converting these two, 110,111 into base 2, adding it to 101,002 will give us the value 100,1011 base 2. That is the result you're going to get. So you see, it's very easy. So using the addition rule and subsequently the subtraction rule also will help you do such a question, solve such a question easily without you having to convert this to base 10 and this to base 10 and then get your result. Do your addition in base 10, further convert to base 2. Subsequently, if you want to know more on these two values, you want to get more on this additional rule and subtraction rule, I do implore you to get our ebooks in our website newtrackmathematics.com.ng. You'll get our ebook and you'll be able to see more further sample questions and more, and you're going to know more on this addition rule and subtraction rule. I want to give you some quizzes and I want you to take out your time. Apart from these quizzes, take out your time, solve these quizzes and go extra miles to solve further questions on this number basis, on this topic, number basis. And remember, you can become a mathematician as you strive as much as you can to solve questions on a given topic. As you do that, if you find any question very, very difficult, just feel free to post it into our community. Register as a member and drop it in our community, and our moderators will be very, very ready in a jiffy to give you a good solution to that question that keeps sleep away from you. So try as much as possible to solve these quizzes that will be given to you in the next slide.